Welcome to MIPI DevCon 2020. Thanks for joining. We're glad to have you with us today. Feel free to engage with the presenters and attendees by using the engagement tools at the footer of your screen. Click Q&A to engage with presenters and group chat to communicate with the attendees. You can simply minimize or maximize each of these icons with one click. To see the agenda, sessions, and demos, click on the Call to Action icon. Enjoy the conference.
Hi, and welcome to MIPI DevCon 2020. I'm Justin, MIPI DevCon Chair, and welcome to the first ever virtual MIPI DevCon from wherever you are in the world. Whether you got up early this morning on the West Coast, or you're staying up late in Asia, or you're joining us for dinner in Europe, thank you for your attendance and support. We have an action-packed schedule full of great presentations and demos from our member companies. You'll notice the format is different than our usual in-person events. We will have 2 days, 4 hours each day, with 10-minute technical and practical demos to break up the sessions from our member company. We will have an opening keynote today, along with a fireside chat to end each day. Today's presentations will focus primarily on MIPI and automotive, while tomorrow we will cover some other topics including 5G, IoT, RFFE, and some others. A big thank you to all of our demo participants and sponsors, as well as our committee members and speakers. Today would not be possible without you. And on that note, I'd like to introduce the sponsor for today's opening session, Introspect Technology. Please stay tuned for a short presentation. Thanks again to Introspect Technology. Now, before I introduce our keynote today, I'd like to remind you that Dervla will share a brief overview of the platform before each session. This will help you engage with the content and presenters, so go ahead and ask those tough questions. So without further ado, I'd like to introduce the keynote for MIPI DevCon 2020, Andreas Locke from Robert Bosch, who will be discussing the future trends of in-vehicle communication networks.
Yeah, hello to everybody. My name is Andreas Locke, and I will talk about the trends in in-vehicle communication networks. So the automotive world is in a transformation, and the megatrends electrified, automated, and connected will determine how future mobility will look like. These requirements have a large impact on the software and electronics of the automotive, hence the EE system. In the past, we had a distributed E architecture. Introducing a new function means to add a further control unit to the system without changing the existing functionality. But the trends of integration and centralization became visible some years ago when OEMs start to bring common functionality from the domains to a central domain control unit. And the aforementioned megatrends seem to accelerate this development because 2-3 years ago, OEMs announced to introduce microprocessor-based integration platforms as server computers in their vehicles. So with the introduction of these server computers, the vehicle's functional landscape and service landscape will change dramatically because technologies and proven concepts from the IT world are brought to the automotive world. So the phenomenon of function repartitioning started in the mature powertrain area. So the engine control unit was one of a few control units in the powertrain area. So this acted not only as a function controller, but also implicitly as the integration platform. But with the advent of the explicit integration platforms, all functionality which does not belong to the core functionality is now brought to these integration platforms. Moreover, OEMs start to divide up control loops and signal chains and rearrange the functionality between embedded layer and integration platforms. This development started years ago in the powertrain area of commercial vehicles, and the benefits are better handling of variance, easier differentiation, more flexibility, and the chance to save cost in the embedded layer by the introduction of smart actuators. But this development also has a side effect. The consequence is that they put more load on the communication network and impose challenges and stronger requirements on the technologies. So let me come to the automated driving. So in the next years, there will be a high dynamic in the area of assisted and automatic driving. We expected two kinds of vehicles. One are the privately owned automated vehicles. They have a limited number of sensors and are capable to drive up to an intermediate automation level. On the other side, we have the urban automated taxis with much more sensors because they are operated in a very complex environment. So they are capable to reach up to level 5. So we have two different applications with two different requirements and two different systems, but they have one in common, increasing number of sensors, which will send a high amount of data to the central computers, and therefore imposes much more load on the in-vehicle communication network. So starting with the requirements. In the top layer of the E-architecture between the vehicle computers, we have the highest requirements for bandwidths and throughputs. In the AD area, as we heard, there are an increasing number of sensors, which a high amount of data, which need to be sent to the AD system. But also in the infotainment area, increasing volume of video data has to be sent to an increasing number of displays in the vehicle. But also the bandwidth in the embedded area has to be increased. Here is a focus mainly of two technologies. One is the 10-base T1S and the CAN-XL. Both technologies are capable to hold one complete Ethernet frame. Some OEMs try to harmonize their technology towards Ethernet in the vehicle, but there is still a lot of legacy communication technology, and OEMs try to preserve their investments. The market will decide which technology will it make into the vehicles, but there will be a long time where we have these technologies in coexistence. And introducing new technologies into the vehicles means adding cost while the number of vehicles stays nearly the same. So with divided control loops and signal paths, there will be also a higher demand on quality of service because the quality of control loops deteriorates because jitter and latency adds noise and makes control timing more difficult. And safety adds another burden. To improve the availability of the communication network in case of failure, redundant communications lines has to be considered to enable at least a fail degraded or better a fail operational working mode. And higher requirements for security makes it even worse. Therefore, time-sensitive networks are introduced. The protocols and technologies are available and will make their way into vehicles. Also, in future, software-defined networks will be considered, because with software-defined networks, a certain amount of bandwidth can be preserved and assigned to a certain device or a specific service. And not only in the case of failure, the communication network can reconfigure dynamically to make optimal use of the communication resources. And with connectivity, also the bandwidth will go up, especially when we step from 4G to 5G. This allows that functions will be shifted from the vehicle to the back end, and in a functional perspective, the back end becomes part of the vehicle's landscape, and therefore the back end can be considered more and more as part of the vehicle's E-architecture. So this slide shows Bosch's view on the technology solution portfolio. Ethernet is already in the vehicle, and CAN and LIN will continue to be used. And we see that there is increasing pressure on technologies like MOS or FlexRay, but OEMs will try to preserve their investments in these technologies. But also technologies from the mobile devices will make their way into the vehicle. So the communication in the top layer between the vehicle computers is dominated by Ethernet at various speeds. So the communication is mainly service-oriented to seamlessly integrate also services from the back end. And standards like TSN and SDN will come more and more to the vehicle to meet all the requirements of higher quality of service, safety and security, and make better use of the communication network resources. Zone controllers will separate the computing layer from the embedded layer. So the communication towards the vehicle computers will still be Ethernet. And in the embedded layer, the legacy communications like LIN and CAN and FlexRay will be used. But in future, also service technology, especially for the connection of sensors like cameras and also displays, the actors, can be beneficial. This diagram shows the bandwidths and the features of used technologies. So at the lower bandwidth side, LIN is still in use. CAN will cover the range from 1 megabit per second to 10 megabit per second, the same as FlexRay, and Ethernet was scaled down to start at 10 megabit per second, but can cover bandwidths up to at least 10 gigabit per second. The connections are point-to-point and are fully symmetric, and if we add two more nodes, then we have to use switches. But in the high bandwidth regime, also SerDes will play a significant role in the future. With SerDes, you can connect sensors like cameras and also the displays. The connections are point-to-point and asymmetric, which can mean cost benefit in future. But all these technologies will coexist in the vehicles, and the TCO will decide on the share of its applications. So in centralized architectures, we already have addressed the requirements, bandwidths and latency. But what about throughput? And the diagram in the upper left shows the demand in throughput, but also the performance curve of today's software-based gateway solutions. And as you can easily see, from 2023 onwards, its limits is reached. Of course, we can add more controllers and more microprocessors, but this is not very cost effective. And we think that hardware accelerators with a hardware-software co-design can lead to very cost-effective and performant solutions. And the upper right sketch shows such a hardware accelerator in combination with a microcontroller or a microprocessor. And the benefit is that CPU is offloaded and the additional resources will lead to increased functionality. Lower latency and lower jitter give more freedom for the repartitioning of functionality and allow more flexibility for the deployment of the software system. This development is disruptive, as you can see from the figures given in the table. So the throughput is increased by 1 order of magnitude, whereas event rate and latency are leveraged by nearly 2 orders of magnitude. Multiple protocols can be implemented in hardware, and there's also hardware support for virtualization and in-band encryption, decryption, and authentication. And also the dynamical reconfiguration is a very attractive feature. So the last aspect is security. So security requirements are normally addressed to the communication network, and security concepts normally consist of a shell model. Bosch uses a 6-layer shell model here. In the first and the second layer, the integrity of software and data, but also the signals and messages in the communication lines are protected by a hardware accelerator and trust anchor, the so-called hardware security module. Communication lines are separated by a gateway and protected by firewalls. Also, the communication to the back end. Here also all relevant standards for external interfaces are implemented. A new development is the introduction of intrusion detection and protection systems. Not only the payload is inspected, but also the routes and the communication behavior is monitored. And if you supervise quite a number of vehicles or a whole fleet, early indication for an ongoing attack can be given. But security starts in the production area. Cryptographic material has to be brought in the manufacturing area, and Bosch uses here a global key management system. To summarize, the megatrends automated, connected, and electrified will lead to immense growth of functionality and higher requirements for safety and security. And therefore, much more requirements for the in-vehicle communication network. So the in-vehicle communication network has to give more bandwidth, better quality of service, and more performance. And therefore, the automotive industry will increasingly build on the synergies between automotive and mobile device technologies like the MIPI standards. And also some automotive requirements might be introduced into these standards in future. Thank you.
Thanks, Andreas. Appreciate that. So I see that we have some Q&A coming in through the Q&A panel. And the first question is, where do you see the highest bandwidth in the vehicle?
We see it in the link for the cameras and also for the displays, because high amount of video data will be sent from the cameras, for example, to the AD system, and also from an infotainment domain computer to the displays. But also there will be a high bandwidth needed for the communication control unit, because some video sequences will always be sent to the backend, and also HD maps in the case of automated driving have to be permanently downloaded to the vehicle. So therefore, I think in these 3 links we can expect very high bandwidth demands.
Very good. Thank you, Andreas. The next question I see, which are critical KPIs for the vehicle?
So if you look into the last years, I think then this was always cost. because if you have a large number of volumes, I think every dollar and every euro counts, which you invest in your infrastructure of the vehicles. But in future, with the advent of electrified vehicles, I think energy and the battery is a scarce resource, and therefore we see also the energy consumption of the whole infrastructure is a critical KPI.
Thank you. I do encourage questions to come in through the Q&A panel. Thank you for those that are already coming in. Another one here for you, Andreas. You were describing the market converging towards Ethernet, yet simultaneously promoting ASI for point-to-point camera contribution. What are the benefits of ASI over Ethernet for this application?
So as I tried to point out is, I think in the case of cameras and displays, we do not need a fully symmetric link. So I think from this perspective, an asymmetric link at the AFI can be very, very beneficial, also from a cost perspective.
Very good. Thank you, Andreas. I do encourage other questions to come through the chat. Otherwise, I did want to let those attendees know, thank you for joining us today, and materials will be available in the on-demand mode following this event. You can always find more information at MIPI.org, that's MIPI.org. Checking the chat panel if there's any other questions coming in right now. I don't see any further questions from the Q&A panel or the chat panel. Again, would encourage those questions to come in. Otherwise, Andreas, if you have any closing comments for your opening keynote, then perhaps you could let us know.
Yeah, I am looking forward also to the success of the MIPI standards in the automotive, and yeah, the next years will show what is really coming. Thank you.
Thank you, Andreas. I do see another question that has come in. Do you think that electrical cables have still a chance in these high-speed demands, or is it time for automotive industry to move into optical communications?
So I think we had a look into optical fibers some years ago, but I think automotive are a harsh environment. So I think electrical cables have their justifications also in the next year. So if bandwidth further increase, I think then we have to think of optical fibers, for example, plastic optical fibers, which can meet all the requirements in the harsh automotive environment.
Thank you, Andreas. I encourage further questions to come in from the audience if there are any. Otherwise, we are coming close to the end of our session here, although we're coming up close to time for our next session. Peter Lefkin, State of the Alliance. Okay, well, thank you very much, Andreas. Very much appreciate that opening keynote. I don't see any further Q&A, so I will say thanks again for joining us, everyone, and stay tuned. You can click on the call to action icon, and that will take you back to the main agenda, and you can see what's coming up for the remaining sessions and demos for the rest of the day. Thank you again, everyone, for joining. Enjoy the rest of the conference.
Thank you.